Good day. So this is our third set of examples ng general antiderivatives, and here we'll take a look at the general antiderivatives of some trigonometric and exponential functions. So we'll start with the general antiderivative of 3 secant x tangent x minus 2 cosecant squared x. So here nakita tayo ng dalawang terms, and both terms meron silang function na may coefficient na constant. So apply natin yung rule natin sa previous na video na pwede natin siyang isulat as constant times the general antiderivative of each term. So we'll rewrite this as 3, the general antiderivative of secant x tangent x, minus 2 times the general antiderivative of cosecant squared x. We can quickly recall, or you can just look at your reference, no, na ang general antiderivative ng secant tangent, or ang function na ang derivative niya ay secant tangent, ay si secant x. So the first term is 3 secant x minus 2 times yung antiderivative ng cosecant squared. But again, you could look at it na ano bang function na ang derivative niya ay cosecant squared, and that will be cotangent pero negative. So this will be minus 2 times negative cotangent x, and let's not forget our constant of integration. And let's just simplify our final answer to be 3 secant x plus negative negative plus 2 cotangent x plus c. Let's highlight this with a box. And you may want to pause it and check kung tama yung sagot. Once you're done, let's continue. The second item for this set of examples is the general antiderivative of sin 2x over 2 sin x. What we want to remember here, no, is that sin 2x is equal to 2 sin x cosine x. So this was taught siguro nung grade 10 ninyo, math 4. So using this identity, we could rewrite our given as the general antiderivative of 2 sin x cosine x all over 2 sin x. Madali na. Kasi makita natin na magka-cancel yung 2 tsaka yung sin x sa both numerator and denominator. This simplifies to the general antiderivative of cosine x, and you're almost done. It's just equal to sin x. Of course, plus our constant of integration. We highlight our final answer. Moving to our third example for this set, we have the general antiderivative of cosine x over sin squared x. So wala naman tayong identity, no? But we'll just rewrite this in a special way. We'll rewrite this as the general antiderivative of cosine x over sin x times 1 over sin x. Ni-split natin yung sin squared sa denominator. Kasi si cosine over sin, that is cotangent x, at si 1 over sin ay cosecant x. And we know that cotangent cosecant, or si cosecant cotangent, this is the derivative of negative cosecant. So the general antiderivative of cotangent x cosecant x is negative cosecant x. Of course, plus our constant of integration. And let's highlight that with the box. Again, pause this and check kung tama yung mga pinagagawa natin. For our fourth example, I want to find the general antiderivative of 1 over 1 plus sin x. So, yung dx na nilagay ko sa dulo, nilagay ko sa numerator. Later we'll see na pwede yon, that dx is actually also a factor by itself, no? Pero para hindi tayo ma-confuse, let's just treat it muna as an operator na kapartner ni integral symbol. So we could read this as a general antiderivative of 1 over 1 plus sin x. And ang trick natin sa kanya ay mag-multiply tayo ng 1 in a special way. So we will multiply 1 minus sin x over 1 minus sin x. So we are multiplying essentially by the conjugate of the denominator. This will give us the general antiderivative of 1 minus sin x all over 1 minus sin squared x. And 1 minus sin squared x is cosine squared x. Pythagorean identity natin from math 4. So we have the general antiderivative of 1 minus sin x over cosine squared x. Ang next step natin ay i-distribute ko si cosine squared x dun sa terms ng numerator. So now we have the general antiderivative of 1 over cosine squared x minus sin over cosine squared x. Si 1 over cosine squared x ay secant squared x. Uy, lumalapit na tayo. Again, I'm distributing yung anti-differentiation operation sa terms. So, antiderivative of sin x over cosine squared x. I-split din natin siya, similar dun sa ginawa natin sa previous item. And we'll have the general antiderivative of secant squared x minus the general antiderivative of tangent x times secant x, which is parehong nandun sa listahan natin ng derivatives and antiderivatives of trigonometric functions. So, anong function ang derivative niya? Ang secant squared, that will be tangent. So, the antiderivative of secant squared is tangent x. Tapos, ang antiderivative ni tangent x secant x ay si secant x. Kaya, minus secant x. plus our constant of integration. Well, let's highlight our final answer. Again, you can pause this if you want and check na tama yung ginawa natin. Then let's move on sa next item. For our next item, we want to find general antiderivative of tangent squared x plus 3 cotangent squared x. Now, let's recall yung Pythagorean identities natin sa trig. Nagsistart to lahat sa sin squared x plus cosine squared x equals 1. So if you divide everything by sin squared, you get another identity. If you divide everything by cosine squared, you get the other identity. The identities are secant squared x is equal to 1 plus tangent squared, and cosecant squared x ay equal sa 1 plus cotangent squared x. So let's apply these identities and rewrite yung given natin as the general antiderivative of secant squared x minus 1 plus 3 times cosecant squared x minus 1. Then let's just rewrite everything as secant squared x plus 3 cosecant squared x minus 1 minus 3. Parang nire-arrange ko lang. And then let's take the antiderivatives of each term, tas kung may coefficient, ilabas natin. This will be the general antiderivative of secant squared x plus 3 times the general antiderivative of cosecant squared x minus the general antiderivative of 4. Pero nilabas ko yung 4 at yung general antiderivative ng dx is just x, diba? We evaluate this term by term. So the general antiderivative of secant squared is tangent x. General antiderivative of cosecant squared x is negative cotangent x. So plus 3 times negative cotangent x minus 4x. Plus of course yung constant of integration. Then simplify yung pagsulat. We have tangent x minus 3 cotangent x minus 4x plus c. We highlight our final answer with a box. Now you can pause this now and check by taking the derivative kung makukuha natin yung nasa given natin. Let's move on sa next item natin. We want to find the general antiderivative of 3 times e raised to 3x. We're using the exponential function. Alam natin na ang derivative ng e to the x ay e to the x din. So, ang antiderivative ng e to the x ay e to the x din. Pero of course, may plus c. Hindi ko yata nalagay yung plus c. So, apologies. And gagamit tayo ng method na hindi pa talaga natin tinuturo. Medyo pinagbabawal pa siyang technique kasi second quarter pa natin siya i-discuss. It's called the method of substitution. But we started using this na dun sa earlier videos. Binibigyan natin siya ng pangalan at gagamitin natin siya for this special case. And then we'll explore it deeper sa second quarter. So we'll let the variable u be equal to 3x. At following yung chain rule, derivative ng u natin ay 3. So 3x and 3. Now, sabi natin that dx is a symbol at iniipit natin yung function na hinahanapan natin ng antiderivative between the integral symbol and yung dx, but it's really a factor na minumultiply. Na i-explain ko later on na lang. So itong weird na to na hindi ko in-explain kung bakit siya factor, it's an offshoot nung fact na the curriculum prescribes na ang approach sa discussion ng antiderivatives ay inverse ng differentiation. So later ma-explain ko kung bakit pwede natin galaw-galawin yung dx. So what we'll do is we'll rewrite yung given natin using the variable u. So 3 times e raised to 3x, pwede ko siya ngayong isulat na e raised to 3x times 3 dx. Para nakita natin na it's e to the u times du. Let's write that as as a general antiderivative of e to the u times du. But kakasabi nga natin, the general antiderivative of e to the x na dx is equal to e to the x plus c. So this is equal to e to the u plus c. And then we just back substitute u, where u is equal to 3x. So we write this as e raised to 3x plus c. So let us just highlight our final answer. Again, you can opt to pause this and check kung tama yung sagot natin. So let's recall first that when say I want to take the derivative of a raised to u, I will rewrite first si a raised to u as e raised to ln of a raised to u. Let's recall na inverses ang exponential at logarithm. So when you take the exponential of a logarithm of a raised to u, magiging a raised to u lang siya. But we are doing this to take advantage of the identity that the logarithm of something raised to an exponent, pwede natin siyang i-simplify by putting the exponent as a factor of the logarithm. So I can write this as the derivative of e raised to u times ln of a. Now, ln of a, since a is a constant, ln of a is also another constant. So let's highlight that here, that ln of a is just really a constant. And if you take the derivative of e raised to u times a constant with respect to u, by the chain rule, this will be equal to e raised to u ln of a times ln of a. Now, recall natin yung pinanggalingan nito, no? Nung e raised to u times ln of a, galing siya sa e raised to ln of a raised to u. So, we can cancel yung e tsaka yung ln, and what we'll have is ln of a, yung nasa kanan na ln of a, times e raised to ln of a raised to u, but sinimplify natin yung e and ln, and all that we have left is a raised to u. Now, if we divide both sides nung expression natin by ln of a, we'll get the expression 1 over ln of a times the derivative of a raised to u. This will be equal to a raised to u. Then, ipapasok natin yung 1 over ln of a, which is a constant sa loob ng derivative, to say that the derivative of a raised to u over ln of a is equal to a raised to u pa rin. And then, we'll work backwards. Kasi we're given a raised to u, hinahanap natin yung antiderivative niya. Antiderivative niya ay a raised to u over ln of a. So, let's write that as an antiderivative. Say that the general antiderivative of a raised to u du is equal to a raised to u over ln of a plus the constant of integration. So, let's use this result now dun sa problem natin. So, first, we'll rewrite yung given na antiderivative of 2 times 5 raised to 3x as 2 times the general antiderivative of 5 raised to 3x. Nilabas ko muna yung 2. So, I can work with 5 raised to 3x. Gamitin ko ulit yung method of substitution. Daya na naman. Na ang u natin ay 3x at ang du over dx natin, derivative niya ay 3. So, ang du natin ay equal sa 3 times dx. Okay. So, I will rewrite yung nasa second line natin and write it as 2 times the general antiderivative of 5 raised to 3x times 3 times dx. Nag-introduce na ako ng 3 para siya yung du ko. So, I need to multiply it by 1/3 para hindi magbabago yung value niya. Pwede ko ilabas yung 1/3 para maging 2/3 na yung coefficient ko. 2/3 times the general antiderivative of 5 raised to u times du. And using yung result natin from the recall, we will get that this is equal to 2/3 times 5 raised to u all over ln of 5 plus c. And all that's left is ibalik natin yung u sa variable na x. And we'll get our final answer na 2 over 3 ln of 5 times 5 raised to 3x plus the constant of integration. Let's highlight this with a box. This is our final answer. You are invited to take the derivative of that expression. Constant lang naman yung yung 2 over 3 ln of 5. And check na makukuha natin yung given natin. So this is the last example for this set of problems. Thank you for being with me up to this far at salamat sa pakikinig.